All right, so we're going to look at area between two curves. So in order to do this, I'm going to review for you what you did in Chapter 5. So in Chapter 5, you dealt with, when you were first starting this, you looked at a curve y equals f of x, and you had this curve y equals f of x. And when you were first doing this, you started with a curve that was above the x-axis. And we wanted the area between the curve and the x-axis between A and B. So we want the area between the curve and the x-axis. First step, we subdivide AB into n equal subintervals. So we're just subdividing it like this. And in doing that, A, of course, is x sub 0, B is x sub n. We have a typical interval x sub I minus 1, x sub I. And what we get is that delta x was b minus a divided in n pieces. After doing this, the next step, the whole purpose of doing this, was to create n rectangles. And to do these, we would have later what's called either a right-hand sum or a left-hand sum. So if I want to do a right-hand sum between any interval like x0, x sub 1, I go up here. That determines the height of the first rectangle. We do the same here. That determines the height of the second. Here, the height of the third. In general, when we're finished, we have n rectangles. And we are now going to look at an expression for the area of each of those rectangles, and in particular the area of the typical rectangle. So A of R sub I is the area of the typical rectangle. Since I'm doing a right-hand sum, here's x sub I minus 1, here's x sub I. We have the function y equals f of x. So the height of the rectangle is the height of the right hand, which is f of x sub I. And then, of course, we know that the width right here, that width is delta x. So A of R sub I is the area of that typical rectangle is the height of the rectangle, f of x sub I, times the width, which is delta x. So our third step is we are going to sum up all those. We're going to get the sum of the area of the n rectangles. That is the sum as I goes from 1 to n of those areas, which is the sum as I goes from 1 to n, f of x sub I delta x. But we just have the sum of n rectangles. That's not the area under the curve. So our final result is we will take the limit. So we take the limit as n approaches infinity of the sum as I goes from 1 to n, f of x sub I delta x. And sure enough, this limit is actually the definite integral. It is the integral, and just like we have in here, this Riemann sum, it is we put in f of x, and delta x becomes dx. And because we want the area between A and B, because we subdivided A and B, those become the lower and upper limit. We now have the definite integral, And this gives us the area under the curve. Okay. Now, if we go back here, we will see that that was the approach to get the area under that curve. But now we're going to extend this, and we're going to have, instead of an area under a curve or between the curve and the x-axis, we're going to have an area between two curves. We're going to go to the next page. We're now going to create a region that's bounded by two curves. One curve is y equals f of x. The other curve is y equals g of x. We want the area between those two curves from x equals a to x equals b. We want the area between those two curves, which is this yellow shaded region. So our first step is we're going to subdivide AB into n equal subintervals again. And that gives us, of course, that delta x is b minus a over n. And in doing that, remember I'm calling this is x0, so the next is x1, x2, and we keep doing this till we get n of these. The last one is x sub n. And when I say the typical one, I mean choose any one of these in here. And the typical one is x sub I minus 1 to x sub I. That will be that typical interval. Our next step is we are now going to create n rectangles that are in this shaded region. See. So I'm going to create n rectangles. I'm going to do the right-hand sum. The reason for that, of course, is because then between x sub I minus 1 and x sub I, the right hand is x sub I. So that x sub I term determines the upper and the lower part of the rectangle. And then we go up here and we work across. So there's one rectangle. And we do this for all n rectangles. So the first one, then we work across. That's your first rectangle. You do the second one. The height there is the upper height of the rectangle, the lower. And basically we create those n rectangles. Just continuing like this, cross across, until we've got, we'll have all of them. Just have all those rectangles. Up here, down here, we go across, across, and we've got the n rectangles. We're now going to get a description of what A of R sub I would be. How do we get the area of that typical rectangle? Because these are all rectangles, so we look at the typical rectangle. Well, any one would be x sub I minus 1 to x sub I. You've got y equals f of x on top. Y equals g of x on the bottom. And sure enough, with that typical rectangle, here's your typical rectangle, we can now come up with an expression for the area of that rectangle. And the area is this length, and that length is the higher value. So this length of this rectangle is the higher f of x sub I minus the lower g of x sub I. So that is just f of x sub I minus the lower g of x sub I. And sure enough, the width we know is our delta x. So we now have an expression that the area of the ith rectangle, which I call the typical one, is length f of x sub I minus g of x sub I times the width, which is delta x. So now the third is to sum up the areas of the n rectangles. And in doing that, we get the sum as I goes from 1 to n, the area of those rectangles, which is the sum as I goes from 1 to n, f of x sub I minus g of x sub I delta x. And now the last step to get the area we want, we don't want just n rectangles, we want the whole region, so we'll take the limit. So the limit as n approaches infinity of this Riemann sum, f of x sub I minus g of x sub I, but the whole thing times delta x. So this is the definition of the definite integral. So the f of x sub I minus g of x sub I becomes f of x minus g of x. The delta x becomes dx, and we are doing this area from A to B. And this is the area between the two curves. So this area between the two curves, notice that kind of have this formula, and f of x represents the upper curve and g of x is the lower. And the typical rectangle will be important because it will tell you from the picture, when you look at the rectangle, you'll see which curve is above and which is below.